Let's look at another example of point estimate. In this example, a random sample of 985 likely voters, those who are likely to vote for the upcoming election, were polled during a phone-a-thon conducted by political party A. Of those surveyed, 592 indicated that they intend to vote for their candidate in the upcoming election. So construct a 90% confidence interval for P, the population that likely voters in the population who intend to vote for party A's candidate. Based on this information, can you conclude that the candidate will win the election? Okay. So in this example, the parameter we are interested in is P, which is population proportion, or proportion of the population which will vote for the candidate of political party A. And the best estimator for this parameter is P hat, which is obviously the proportion of the sample, or sample proportion, which took part in the phone-a-thon. Okay, so P hat is equal to x divided by n. X is the number of the people who are intended to vote for the candidate of political party A. So those are 592 divided by the sample size, which is 985. So our sample proportion is 0.601. And now we calculate standard error, which is calculated as P times Q divided by N square root, which is equal to 0.61, and Q, we know that it is equal to 1 minus P, so it will be 0.399 divided by 985 and whole square root. By calculating, we get the value 0.016. Okay, now we can construct the 90% confidence interval for P by using these values of P hat and standard error. P hat plus minus Z alpha half times the standard error. Here alpha half can be understood by plotting this normal distribution graph. This is the normal distribution. This is how this normal distribution graph looks like, and we know that the middle or the center of this graph lies at mean of the parameter, or Z is equal to 0. And on the left, on the right side, Z is positive, on the left side it is negative. So alpha half is actually alpha half on the negative side or left side, and alpha half on the positive side. We within these boundaries, or within this interval, we assume that this is the 90% confidence interval, and the leftover on each side is 5%. So 90% is within the interval, and 10% divided by 2, 5 on each side, 5% left side and 5% on the right side. So this is the interval which lies outside the 90%, but we are interested only on the inside portion, 90%. But to calculate this 90% region, we have to exclude this red highlighted portion of the graph. and 5% area is covered within minus alpha half, and 5% area is outside plus alpha half. And we know that total area under the normal distribution graph is 1, therefore 5% of 1 is 0.05. So plus 0.05 and minus 0.05. Therefore we can write our 90% confidence interval as p hat plus minus z of 0.025 times SE, which is 0.016. Now we can calculate the value of z for 0.05 area, and we will find that the value of z for this value, you can use your calculator or you can make use of the tables, those are given, that z for 0.05 is equal to 1.645, and we multiply it with 0.016. Now we insert the value of p hat, which is 0.601 plus minus 1.645 times 0.016 is equal to 0.026. So this is our confidence interval, which is represented as 0.575 and 0.627, or in the percentage form we can write it like the population proportion which is in favor of the candidate of political party A is between 57.5% and 62.7%. Now if we assume that the candidate needs 50% votes to win the election, our 90% confidence interval says that it is within 57.5 and 62.7, which means that we can say with 90% confidence that the candidate of the political party A is going to win the election. This is our conclusion based on the given data.